Hello, my name is David Meltzer. I'm the Secretary General of GVF. GVF is the Global Trade Association for the satellite industry. Our members are from all continents of the world, save Antarctica. And importantly, our members represent the entire satellite ecosystem. And it's my pleasure to moderate a panel which will really discuss satellites' resilience evolution. Notwithstanding challenging markets and the need for robust connections, the satellite industry has certainly responded to those needs. And it's my pleasure to now introduce our wonderful panel. Certainly, I think a lot of people are very familiar with all of these companies, but certainly would like to introduce Alvaro Sanchez. Alvaro, as many of you know, is the Chief Executive Officer of Integrasis. We're also very fortunate to have Jack Buechler of Thalia. Jack is the Vice President for Business Development and Product Management. And finally, Nicholas, or Donnie as he prefers to call Lawton. Donnie is with Telesat, and he is the manager for the systems operations of their LEO system. And I know we're all keen to understand Telesat's plans in LEO. So with that, let me have all the panelists join us. And gentlemen, welcome, and thank you very much for joining. As I mentioned, the title of the webinar really discusses the robust connections provided by satellite communications. And I'd like to ask each of you, what's your interpretation when we talk about robust connections? What does that mean to you? Let me start with Donnie. Donnie, you're very much involved on the technical side, and as I said, on the LEO. How do you address, I mean, certainly it's a customer desire for robust connections. What's your perspective, Donnie?
Thanks, David, and it's a pleasure to be here. So when we think about, I guess, the term robustness from the perspective of Telesat LEO, it's really about, does it stand up to the types of events that might introduce deterioration in signal quality or service, right? So we've been spent a lot of time thinking about how to engineer solutions that handle the types of events like fade events or interferences that might impact services that we deliver to our customers. And so that's why we've introduced things like our phased arrays on our satellites, which allow us to shape our beams and accommodate for different types of channel effects, optical inter-satellite links, in order to ensure service around interruptions in serviceability, perhaps if a satellite has a sun outage or those sorts of things. So I think about robustness, for us, it's mostly about making sure that the service is stable and that it's available when required by our customers.
Okay, so service stability, that seems like a goal all the customers require. Alvaro, what's your perspective? What does robust connections mean to you?
For us, it is 4 nines. So 99.99 is what it is, a robust network. So as Nicholas mentioned, interference is a key issue on a non-robust network. We mitigate that interferences. We also calculate how much is the service level agreement that you are complying with in order to report to your customers in carriers, in services, in channels, and the overall SLA of each teleport or the global network. So in that regard, for us, it's extremely important to provide a very intuitive interface to prove how robust is a satellite operator network or a service provider network or a government network that we work a lot with. And also we have new tools that enable to do very, very accurate link budgets in order to have robust networks again, in order to design and then with other products deploy, and then with other products mitigate interferences or maintain, and also provide an SLA automation report that shows how robust is your network.
So I think an important point you make when you talk about 4 nines, you emphasize you're talking about the network as opposed to, because often on the satellite side, often the satellite component of the network provides in excess of 4 nines. And I think the other important point that you made is this service level is woven into your contract. So you better meet that 4.9 requirement. Thank you. Jack,
Thank you.
what's your perspective? Is it similar or is it additive or different from what we heard from Donnie and Alvaro?
Definitely additive. But what I'd like to point out is, and we'll come to this later, but it doesn't matter how much money somebody pays as a service provider, even if it's $10 a month, even if it's $10,000 a month, the customer wants a good quality service, and that's robustness comes into it outside of the price they're paying, down to your home broadband or to your satellite service or whatever it may be. And in fact, from a service provider point of view, we certainly don't want to have a service that's not reliable, because actually it costs more to provide a service that's not reliable because you have to keep going back. So all the tools we've just been speaking about are very relevant to providing a robust service. And like I say, who wants a service that's, I mean, have you ever seen an advert that says, do you want an unreliable service? No, of course not. And robust to me means reliable, planned for all eventualities. And at the high end, you have energy companies using maybe 2 links, or in some cases even 3, maybe a terrestrial major and a satellite minor, or where that's not available, 2 satellites on 2 different bands to avoid issues, different satellite providers, many different ways to mitigate the problem. But certainly on an end-to-end basis, it needs to be up there and available. Depends how much somebody's willing to pay for that robustness, because there comes a point when it could fall over, however many lines we measure.
Sure. And so there's a follow-up question for all of you, and I'll start with you, Jack, since I think you referenced the possibility of interference as being certainly a concern. And so when we talk about robustness, and Alvaro talks about 99.99, that's an extraordinary high standard. I think a lot of telecommunications providers aim for that and don't achieve that. But it also implies that there is that 0.01% of the time when something happens. And robust does not mean invulnerable. So what are the types of vulnerability that you worry about, Jack? And are your worries different than they were 5 years ago, or looking forward in time, do you think you'll have different worries when it comes to vulnerability? What do you think, Jack?
I think there's a lot of vulnerabilities coming from political angle, much more so today than we saw 10, 15, 20 years ago. The political scene and the ability to interfere, block channels and things like that has become much worse as the medium has become more widespread and mature. So I think we are careful of that. We do see interference from 3G networks running in the C-band, particularly in Africa, where the microwave isn't always regulated as well as it is in the Western world. And we have to take precautions to avoid that almost at every single site now. And it's a real problem. So yeah, that's microwave interference is what up there. Political is as well.
Yeah, so 3G, the C-band, and political interference are what keep you up at night. Alvaro, just similar worries, and what do you think 5 years from now? Are you going to be losing sleep at all, or losing more sleep?
I lose sleep because my wife is pregnant, but for now, not satellite issues. No, the network needs to be robust, but also resilient. So it is a key requirement to solve problems very fast when they happen, because problems, they do happen. They can happen terrestrially with 5G, 4G, 3G, or it can happen in the satellite, people that try to interfere because they don't like the content, or people that try to sneak what information you are transmitting, or people who do not know anything about satellite, and they are certified or non-certified as installer and try to install. So without the right tools. So this is something that happens. It happens in every kind of network, whether it's government, whether it's enterprise or consumer, and also faulty equipment. So it is important to be able to solve the problems when they happen, and this way we make all the satellite more reliable, even more than the SLA, or even more to let's say non-perfect service. So this is something very important, the resiliency. And I would say that what keeps me up at night, it is that now the industry, it is in a challenging market, as it says in the title, because capacity is dropping down in price. And also COVID-19 is not enabling people to do business as they used to be. So people is not meeting with their customers. I used to travel a lot. I am not traveling anymore any day. So it is a very different environment that we are living. So we need to innovate on how we do business and how we do seminars, as GVF has done great with Cabsat, or how do we interact with our customers, the people out there that can buy our tools or can buy your service, because they might not be from our industry, they might be from other industries, but we need to talk their language and we need to adapt new ways of selling. That is now what everybody needs in this industry.
Thanks, Alvaro. And you talk about the speed to respond when an issue does pop up, and that's obviously critically important from the customer's perspective. Donna, you're in a unique position in that I think you're designing a network, so you have to anticipate a lot of issues that may come up, but you don't necessarily in the LEO context yet have that experience. So what are you worrying about in terms of the vulnerabilities? What do you foresee as the main challenges, and what are you planning on doing with the LEO system?
And Alvaro, congratulations. My current worry is that my 2-year-old will run in and interrupt this call. So that's the current worry. I think that there's kind of two answers to this. One is more of a forward-looking answer. So even though we're deploying an NGSO system, we're still using the same fundamental air interfaces that satellite systems use today, right? So we're still a DBS2X RCS2 system. And so those technologies are still applicable. And so when we think about what we need to worry about from an interference perspective, it's the same things that might harm or interfere with geostationary systems. And a lot of what we do in terms of designing systems is leveraging large-scale climate data sets to have a good understanding of what margins we need, how much power we're going to need, what fade slopes we're going to experience in order to design our system to be resilient and robust to those things. It's clear that those data sets that have been collected over the last little while are changing significantly due to various effects related to climate change. And so it's important that we take that into account when we think about our long-lived systems and making sure we've designed adequate margins in our orbital assets, right, to account for maybe a different climate and weather environment that we might face in the future. So that's vulnerability number one. The other one is related to what Alvaro said, which is around being reactive. So as systems get more complex and we need tighter reaction times, we tend to introduce automation, which is something that whenever you introduce a computer supervising a closed loop response, you have to have a lot of faith that you've automated it properly. And one of the guiding principles that we've adopted here is you automate what you understand. And so certainly deploying a new system with a new network, there's some things we may not yet understand that we'll discover once we start operations. So my effort has largely been around trying to mitigate the vulnerability of automation, right? Which is something where you trust a system to respond in a certain way by design, and it gets stimulated with something that you did not anticipate. And that can be anything from, a reaction to an interference or a reaction to a cybersecurity event or any of these sorts of things, right? So that would be the second part, is trying to make sure our system is flexible enough to accommodate what we don't yet know.
Thanks. And I very much like the phrase when you referred to the vulnerability of automation. You've all mentioned the issue of interference, and I'll start with Alvaro. Jack had mentioned interference in 3G networks. There's a lot of interference can be caused by adjacent satellites, by terrestrial networks. 5G is rolling out around the world. What do you worry about? In addition, some countries are allocating portions of the C-band spectrum to mobile, and that obviously creates other risks of interference. What are you, into your company, what is it doing to mitigate the risk of interference, and what worries do you have? Since you'll be up in the middle of the night with a young infant anyway, you should just tell your operations team to call you and you'll be awake to fix their problem. So what problems do you anticipate at 2 a.m.?
So one of the problems that I'm anticipating that it was not mentioned was how the LEO and the MEO and the GEO will coexist without interferences, how also flat panel antennas, which are flat, will coexist with adjacent satellite interference, how new technology will evolve, how the orbital debris will be tackled, and masses of satellites being launched won't crash to another satellite in the near term. This is physical interference, but it's also interference. So yes, I'm looking at multiple worries. What we are doing now, it's multiple technologies. We have SatMotion that a lot of people know for installation that mitigates cross-pull and adjacent satellite. But we now have SatMotion API that is patented in the US, and it is completely automated with a flat panel antenna or a maritime antenna or a common deposit antenna. So no human interaction is required. It's embedded on the ACU of the antenna, and it's just a RESTful API that does everything for the commissioning standpoint or for the revalidation standpoint. We also have systems at the hub side that can revalidate any remote that is sailing or flying. We also have tools, and we are working on tools for interference cancellation for 3G, 4G, 5G, for LEO, for Earth observation, for geostationary satellites, and government networks, private networks, any kind of networks in a cost-effective manner. So this is one of the newest initiatives that we are doing with the European Space Agency as we speak.
Very good and very interesting. And Donnie, Alvaro mentioned, the issue of interference, LEO, MEO, GEO. What's your perspective on that? Is that a material risk? If so, how are you trying to mitigate it? You obviously, as Telesat, you have your own GEO systems, so that's a legitimate concern, I suspect. But what are your thoughts, Donnie?
Yeah, it's actually what I was going to lead with, David, is that we operate GEOs as well. So we have a fleet of geostationary spacecraft that are in-band to our LEO system. So we certainly appreciate some of the concerns that Alvaro is raising around how we can coexist in a plurality of orbits, right? And I think Telesat has actually led the way, especially at the ITU, in terms of how we manage satellite interference between NGSO and GSO systems. So Mario Neri spent a lot of time at the last WORD conference and has chaired that committee for a while on how we manage EPFD. And my team is largely responsible for what we call our system resource management function, which is the entity that kind of uses information about other people's assets, about how they're operating, to ensure that we operate on a non-interference basis. And Telesat's got a 50-year history of operations. The satellite industry only works if everyone kind of plays nice and coordinates. And we're seeing that already. So we've already started to establish coordination agreements with our the fellow members of our industry, and we surely anticipate that that will continue. I think the main issue will be around ensuring that information is available, right? That we understand where, on potential geometries, interferences might occur, so that we can mitigate them. And so it's a challenge sometimes when you're competitors to establish some degree of transparency, and it's useful to have organizations like GVF, for example, that facilitate those conversations, so that all the data is available so people can operate in good faith.
Thanks, Donnie. So Jack, interference. You've heard from Alvaro and Donnie. Are there other areas that you worry about, and what are you and Talia doing to mitigate the risks of interference?
Well, we see two things. Somebody mentioned before about C-band, besides myself, and we have actually seen one country outside of the EU saying there's no more C-band satellite coverage, even though there's coverage of satellite of that country. They said, no, we are not permitting any inbound or outbound C-band unilaterally applied. So that's one way of mitigating interference in C-band. You use KU band or KA band or some other band, S band or whatever. So that's one way of doing it. We do see in Africa a lot of people breaking the rules. And they're not the large companies. They're small companies. They tend to be small companies that need a link between 2 points, and they just go and buy the microwave and point it, and off they go. And that often is a harmonic of C-band that we're transmitting on. We have to take, in fact, we just do it naturally now, and we just do certain mitigation to stop that at every single site. Even before we don't try and see if it works without it, we just do it, because we'll get stuck otherwise, and we might as well ship that equipment. It's hard enough to ship it as it is, so we'll just ship those things in and stop it. So we do see it regularly, particularly in Africa. Middle East less so. It's much more regulated, but Africa, yes, big problem.
Okay, well, thanks. So for the next few questions, I'll just open it up, and if you want to respond, just raise your hand or just let me know one way or the other. But Jack, you just mentioned the a regional perspective, and I'd like to hear everyone's thoughts on what are the customer requirements, how do they differ by region? And obviously, this panel is appearing during Cabsat, where the audience will be global, but many in the audience are from the Middle East and North Africa. And I'd appreciate hearing your thoughts, if you have them, about that region in particular. What are the customers demanding from the region? What sort of unique aspects do you see on a regional perspective, and in particular the Middle East and North Africa? So who would like to tackle that question? All right, Alvaro, thank you for volunteering. Go ahead.
So we have managed to penetrate both markets, but we have a higher penetration in Middle East. In our view, Middle East is looking for the best solution to a price point that is decent. And up to now, they have been demanding CapEx models that will enable us to grow. And we have been growing significantly in this market since 4 or 5 years back. On the other hand, in Africa, we are looking at a lower CapEx possibility, more an OpEx solution, which we have been very lucky, because our customers in Africa has been very reliable with the payments, and in many cases more than the customers in the US, which is curious. But to be honest, we have been very lucky. It's not always the case, but in Africa, it's more an OpEx kind of solution, a little lower in the licensing and in what they are looking to. Sometimes they propose you to have, let's say, a middle solution between the one that you have and the cost that you require, because it's the best solution. So you need to adjust in that regard and look at creative ways to make business in Africa. It's not the easiest market. It's not the most secure market, but it's a very good market. Just to give you an idea, when COVID happens and after satellite, after the pandemic, most of the markets were very slow, but Africa didn't have COVID yet. And for a couple of months, we were receiving a lot of orders from Africa because that dynamic, the world is global, but not everyone gets at the same time. So the effect has been over the last few months, but from March to June was actually for us a very good time in Africa, which was not the same in Middle East or the US or Europe.
Interesting. So, Jack or Donnie, any thoughts that you want to add in terms of customer demands from a regional perspective when it comes to reliability or resilience?
Yeah, I'll answer to start with. We see it by sector as well as by region, and it doesn't matter how much somebody pays. They want a quality service at the end of the day, and we're seeing some very complex requirements down at what you might call the bottom end of the market, the smaller bandwidths. At the higher end of the market, we're seeing demands, particularly from energy companies, both in Africa, where we're doing a lot of work with O3B, and in the Middle East, particularly in Iraq. Customers want robust solutions. We spoke about robust solutions, but they're looking for fiber and satellite as well together. And it's not just, as we mentioned, David, earlier at the beginning, it isn't just the satellite portion. In order to maintain, and I've been talking about this for almost 2 years now, the satellite market, one salesman called me this morning just before this call and said, every time somebody calls me for a service, they want and it's a renewal, the price, they always want a discount and the prices are going down. And we all know that. And most of all, so does Talia, because we're a large purchaser of capacity. So we saw other markets and other people asking for lower prices. Customers are demanding lower prices. The markets are much more mature today than they were 20 years ago. So the prices are falling, and what are we going to do about it? Gone are the days of having a teleport and providing an iDirect service. That's over and done with. Customers want end-to-end service. They demand it. They want additional routing, in some cases extremely complex routing, which we have to provide. Manpower on the ground when there's a fault or an outage. You know, they want 1 or 2 hour responses in some very difficult places. Those are the types of things we're seeing, and forever increasing, in some cases, lower prices. So it makes it very hard to maintain. And the only way to do that is economies of scale and providing value-added services. There is absolutely no other way. Otherwise, it's a spiral right down to the bottom. And in fact, as we all know, Talia itself offered a service for free a while ago. And what you find there is that people still want the level of service, even for free. Free is not enough, actually. So actually, you're talking about negative values. And again, I did talk about this at GVF almost 2 years ago, and was laughed at actually by some of the companies that were 20 or 30 or 50 times bigger than us, who have now gone out of business, by the way. So, or they're in chapter 11 or whatever. So, you know, they were laughing at us, but actually it's come to fruition that in some cases you could have a negative price for a customer. That's because it's bundled with something else to make up the numbers, if you like. And the overall blended margin is good for both companies, both for the customer and for us. So that occurs as well. I'll give you a bit of a picture there.
So very challenging. let me change things up a little. And I think there was someone mentioned flat panel antennas before, and certainly that's one innovation that is certainly emerging in the marketplace. When we talk about robustness, what are some of the innovations that you all see coming down the road that will facilitate robust connections? Who wants to take that first? Okay, go ahead, Donnie. Yes.
Sure, yeah, I think that's actually been a guiding principle, and one of the reasons why we are pursuing an NGSO constellation is to deal with some of the specific concerns about robustness that are attached to geostationary networks, right? So the fact that you don't have flexibility on geometry, you have to point the dish at a particular satellite in a particular direction, and if something comes in between those two things, you have difficulties, and you don't have many other options if you're only on that satellite. We do believe there's a place for geostationary networks, by the way, in the ecosystem of Satcoms. So it's not that geostationary networks don't belong. It's just that some of our customers have been looking, especially our mobility customers, where their local operating environment changes as they move, are looking for options to select a different satellite to route around a problem. And so that's, I think, an important NGSO as a paradigm that we're trying to leverage in our business. The other thing I would say is just, and I revisit that automation piece, but data, right? So as cloud technologies become more accessible to operators, we can generate and consume large volumes of data, which allow us to look at trending, look at ways of operation in near real time that just wasn't possible before. And we're leveraging those economies of scale on the hyperscale providers to conduct these types of analyses. And that in turn allows us to operate in a way that counters the natural tendency to just add margin to introduce robustness, right? But when you add margin, you leave sellable capacity on the table. So how do you operate in a way that preserves, that link reliability that we're looking for, but lets you increase your utilization from a customer basis? And it starts from data and the ability to manage large scales of data. And from that perspective, I think it's really important. The last thing I would say is that one of the challenges that I think all satellites going to face is we've tried to make ourselves more seamlessly part of what we call the terrestrial network ecosystem, right? And so, interoperability, having standardized interfaces, basically trying to make our customers agnostic to whether they're going over a satellite or other network media, right? One of the challenges we'll face as an industry is that comes with a concomitant set of expectations, right? That maybe didn't exist before. So when the customer doesn't know that they're actually going over a satellite, they just know they have a network connection and something goes wrong, right? They're expecting the same MTTRs, right? The same SLAs that they'd expect on the ground. And so we need to be prepared to respond in those ways. And that's certainly going to be require these new technologies that I referenced earlier.
Good thought. Thanks. Alvaro or Jack. Jack, why don't you take this issue of what are the technological innovations coming down the road that will improve reliability and robustness?
We certainly think the LEO systems are important, and the sooner we can get a flat antenna, as we just heard, that can do what we want at high bandwidth, almost the better. Now, just to remind everyone in the audience that satellite receivers, just receive only, basic stuff you can get for $50, I don't know, something like that. These days with antenna, that used to cost a hell of a lot more. That used to cost $1,000 or more than that when there were lots of little companies generating. When DVB came along, all of a sudden in a standard, that changed the world. And we have receivers now right down on the low price. I have no doubt that there will be flat antennas able to do pointing. They are around now, and they have been around for 50 years actually, but not doing what we want to do in mass production. Our defense friends have been using them for a long time, particularly on the front of missiles. So that type of thing will help us, will help everyone. But that's not the be all and end all. That is not the end game. The end game is what happens behind that. And yes, for the home broadband user, that's fine. But for the enterprise customers, that is not acceptable. That is not enough. There needs to be more than that. And that's why network providers like us are still in business and will be for the next, I don't know, 5 years minimum, before some of the market at the bottom gets changed out. But certainly the middle and the top end won't, not for some time, because customers are not, quite often our customers might be having an HQ in the US, but actually their remote offices are somewhere else, and they physically don't have the facilities. We also should never forget about regulations. And in some countries, regardless of the capability of the LEO system, it does not permit you to transmit out of that country. Now, again, we hope, and that's how I started the GVF myself, to balance off all of the players, and not one company go forward and say, we have a license, but across the board, the GVF would go to that as a group represented by you, David, to go to that government and say, look, these are the benefits to you, X, Y, Z. And so I think there's great things coming. I don't think we're there yet. I haven't seen the price points low enough to fight down at the $250 level yet. But I'm very hopeful, because I think mass production that will, and today mass production is ever easier, from drawing board to physical product has never ever been easier. So I think we will get there in a much shorter time. I don't think it's going to be that long. And in fact, our friends in SpaceX announced yesterday a $499 terminal. Well, that's going in the right direction. Definitely going in the right direction as a beta. So definitely in the right direction.
Yeah, Alvaro, let me get your thoughts, and then Donnie, back to you. So Alvaro, what are your thoughts about FPAs or other innovations? Go ahead.
I'm excited about the new LEO MEO constellations that bring investment into the satellite world. So this is very important, because it keeps our industry growing, if not flat. So one example is we work a lot with Cabsat. If Bill Gates is investing in Cabsat again, they have more budget to have better tools. And it's a very similar process with flat panel antenna manufacturers, which are absolutely mandatory for those LEO constellations from LeoSat or SpaceX or Amazon that will eventually succeed, maybe sooner or later, depending how many satellites they launch, and depending on how good is their service. But with no doubt, they will not be connected with mechanical antennas that might break, as O3b is. It is very challenging environment to move all the time the antenna from in many satellites. So LEO satellites are much more number of satellites than MEO, and it will be not robust at all. So also, if you look at the ball flat panel antennas, traditional for planes, they are much more expensive than a Cabsat is. So price is coming down, and price will continue to come down in order to meet the demand. It will be this year, I doubt it. It will be next year, maybe, and we will be going in the right direction. But again, we won't have a cheaper flat panel antenna with what it is a dish today. So this is our very cheap, and it won't go down there a flat panel antenna, but at least for transmit and receive. Because there are many parts, a lot of intelligence, and it needs to be accurate in order to not kill the industry. So it needs to have the right commissioning, the right interference mitigation, the right tools embedded on the antenna in order to streamline that process and work with LEO or work with MEO or work with GEO in order to be capable of benefits, as they say, one size doesn't fit all. So to benefit from all the type of orbits.
Thanks, Alvaro. For the Telesat LEO system, what are your thoughts on antennas? Correct me if I'm wrong. I think you're focused on enterprise customers as opposed to consumer applications. But what are your thoughts?
Yeah, I think both Jack and Alvaro have brought up some really important points, right? So certainly, we've actually made strategic investments in flat panel antennas to help build that ecosystem, specifically to ensure that we had qualified antennas for our LEO system when it arrives in 2023. And we've worked with companies like Kymeta and Ball on making sure that the requirements to serve NGSO constellations are incorporated in their roadmaps. And I think it's one of the things we've seen actually is that the flat panel antenna ecosystem can leverage investment from other industries. So 5G, the 5G standards include steerable beams and flat panels. So we're seeing actually a lot of sort of adjacent investment in the same technologies that we intend to leverage for LEO from a 5G perspective, which I think is just an example of the fact that wireless communication, right, tends to have some foundational technologies. And we're seeing a democratization of those foundational technologies across ecosystems, not just satellite. And that's where I think it's really important to call a couple things out. One is satellite as an industry will never be large enough to establish the critical scale that we see when we see things like cell phones, an iPhone costing a reasonable amount because they sell 200 million units a year, right? So we need to be able to leverage that adjacency to those other industries. And so that's where we've tried to make those strategic investments. I'd say the other thing too is that in the GEO ecosystem, we have had steerable antennas for a while, and what some of the key verticals for NGSO systems are also the same. Have previously been served by GSO systems, but are just facing issues around robustness and capacity that we hope to solve with our LEO platform. And so those steerable antennas that you see on maritime systems, on aviation systems, we've been working also with those partners, those antenna partners, those terminal partners, to make sure that our customers have a roadmap to adopt LEO, even if they make investments in those steerable systems today that target GEO. And I think the last thing is we're seeing a lot of innovation in this space independent of all of that. So you've got guys like Isotropic who are coming up with whole new ways of developing flat panel. I think Alvaro was the one who mentioned that the ball antenna is, extremely, or the standard ball antenna, I should say, is expensive for various reasons, right? Not just the technology, but other reasons. And so it's, we're seeing these other innovations that I think were sort of spurred by investment in NGSO constellations is going to benefit everybody, including the GSO systems and including us as a GSO operator as well.
Okay, so sounds like a lot of innovation has already hit the market and will soon hit it, and that elusive goal of a low price consumer application flat panel antenna, perhaps. Well, it's not here today, but hopefully not too distant future. We're coming up probably another 5 or 10 minutes left in our time. And I did want to bring us back to the question of the market, the Middle East and North Africa market. We've talked a few minutes ago about from the customer's perspective and their requirements. What about any challenges that are unique, or if you will, not unique, but certainly endemic within this market regarding connectivity, robust networks? Do you see in the Middle East and North Africa any particular challenges around robust connections? I think, Jack, you mentioned regulation, and that certainly can impact connections. Alvaro, what do you think?
I think that nowadays the government networks in the Middle East are getting more and more traction, more and more importance. They are more, and they need to be highly reliable. Let's say the King's network for their jets or their Land Rovers or any kind of government network, whether military, it could be an example, in the Middle East is creating more and more importance, and the requirements are a little higher than they used to be, and they are welcome to adopt new things and new tools and new softwares and new services and new kind of proposition, and they are eager to improve what they already have and to make it more robust, reliable, and efficient. So this is a market that is very active and very good with a lot of requirements. So we see as a very good potential to grow even more in the region.
Thank you. Donnie, any thoughts around that?
Yeah, I think market strategy and market specific analysis is not really an area of the business that I focus on. I kind of more of from a technical background. Mm-hmm. But one thing I'd share is that as kind of piggybacking on Alvaro's statement about government requirements, historically we've seen that most government specific Satcom systems were bespoke, right? So they were very they're very tailored to a particular mission, for the government consumer that purchased it. And now what we're seeing is governments looking to leverage the commercial scale to kind of to spend their tax dollars more wisely. And you see that in other industries. So for example, cloud, in the cloud industry, you're seeing governments adopt cloud kind of globally so that they can share the burden, the basic operation burden with the commercial sector. And from our perspective, we're building a platform so that government users can share the operational burden of our LEO system across our entire customer portfolio. And I think that will yield benefits in every region, including ones where government requirements might lead to more stringent, sort of SLAs, if you will. But also more generally, I think in any region where they're looking for, the ability to tailor their SLA to the mission, right? As opposed to sinking a large capital investment upfront for a particular region, which may or may not be required, and for which there's little flexibility to adapt later.
Well, this is extremely important, and it is a very good point, Nicholas. But we have seen it, at least from the government side, that sharing they don't like. They like private cloud. It's cloud, but they need to be private and secure, and only they can see and only they can interact. So that's something actually a great comment. But at least our feedback is absolutely control, secure, and private. That's a very key requirement.
It's a good point, Alvaro. I think what I was trying to reference was the idea that the platform that is used to deliver those cloud services, it benefits from a commercial investment. So if you look at, for example, my most recent familiarity is the JEDI contract in the United States, where the US DoD has signed a $10 billion contract to Microsoft Azure. Microsoft didn't reinvent Azure to deliver that contract. They changed its deployment, right? So all the investment in NRE and the foundational technologies of Azure are still being leveraged there. And so that's why they can get economies of scale, perhaps on target specific private data centers, but certainly the foundational layers of the technology layer are benefiting. And I think that's the same approach we're trying to take, and I think all satellite operators actually are trying to take in general, right, is build a platform that they can tune into the specific needs of a customer, so that they can share that sort of, the basic software. You mentioned, I think, RESTful APIs for antenna control, and I'm sure that those APIs, secured properly, could be used to control a spectrum of antennas from ones that maybe have a less stringent, requirement on the SLA and one that has more, right? But you can use the same foundational technology. And so I think it's important to call out the privacy aspect, but the only way we scale better in terms of commercial investment in satellite and in any technology is to share the load where a basic platform can support a plurality of concerns.
Thanks. Jack, any thoughts on this topic?
Yeah, Jack, absolutely. Sorry. Absolutely. first of all, I mentioned regulatory. That's a really big topic for many countries, mostly because of security. And when we come to the Middle East and certain parts of Africa, there's a big concern on the security aspect of what's going in and what's going out. As we all know, for robustness, where we started, the satellite doesn't have to rely on the local terrestrial. Well, that's a problem. And it's an even bigger problem with LEO, because of course it never goes locally, it always tends to go up to the satellite and through some gateway. And that leads to another point when we're talking about innovation, and we see the satellite operators more and more trying to provide network services as well. So we have to keep ahead of that, otherwise we're not the owners of the satellite, unfortunately, so we don't set the prices, and that always causes a problem between the satellite operators, who most of them, the vast majority of them, say they don't work to the end users. I beg to differ, and what a company like us, a service provider, does, so providing service to end users. And what's the difference? So where the network innovation comes in, we have to bring in other services, sometimes terrestrial, or some other complex routing solutions. The other thing is the market and customers, particularly high-end customers, are getting used to this. This is not the first network they've had. After 3 years or 5 years or more, are renewing their networks. So firstly, they understand the service side issues and what's out there. It's become much more mature, a bit like everybody, even a kid knows about an iPhone, right down about the latest iPhone 12 just come out. They all know about it and why it's better than the iPhone 11, so they also know about the satellite market. And I'll give you an example. We just entered into an RFP with over 400 questions on it. So mostly to do with satellite, which I've never seen before, asking questions that even the satellite equipment manufacturer had to go back to their own labs and test. So that gives you an indication of how far people are going to, or customers are going to, compare different providers. And that's good and that's bad, because it keeps people out who don't meet the requirements. And I like that, because we're a company that tries as hard as we can to maintain the regulations and the requirements. But it's difficult if you're up against people who don't spend the money and the effort to provide what I call proper service. So that's some of the issues.
Okay, thanks, Jack. Alvaro, I'll give you the floor as the final speaker before we conclude this webinar. So Alvaro.
So it was actually a comment to Jack. You were getting all the competition now as satellite operators, modem manufacturers in particular areas, other service providers, and also antenna manufacturers that they provide service. So you need to differentiate very much your service from other people's service, because it's a challenging market, as the title said. So I highly believe that the service providers, they do have a role to play. We work with a lot of them, and it's a great pleasure. They have they know very well their customers. They know very well their customers' challenges. They know how to serve their customer challenges. And we highly believe that they are there for a reason and will remain there for a reason, because it is something that they have a lot of experience with, that satellite operators, they don't, that equipment manufacturers, they don't, and that antenna manufacturers, actually, they do less. So what I would say is that the role of the service provider is critical, but they need to adapt to new times, do better alliances with satellite operators, equipment manufacturers, in order to make their business a success and not bankrupt.
Okay.
Definitely agree. on
Well, we are out of time, gentlemen. Want to thank everyone for your, not just your participation, but excellent discussion, excellent answers, and very much appreciate our hosts at Cabsat for this opportunity to present some very interesting perspectives on satellites' resilience, evolution, and thank you again. Goodbye.